This message is sent directly between these two phones, completely off-grid, without using any Wi-Fi or cellular connection. Each phone is connected to a small, cheap, battery-powered radio device, and those radio devices can communicate with each other. By adding more devices, they automatically form a mesh that messages can jump through over long distances. This is known as Mesthastic. Mesthastic has become quite popular recently, so let's take a look at how it works. First, theoretically, and then practically. And then later on I will tell you about an even better off-grid alternative to Mesthastic. I'm standing in a field and I yell out, "My name is Snoren. Repeat this message 3 times. Just within earshot of me is another person who hears my message and yells out, "I just heard a guy named Snoren. Repeat this message 2 times. Within earshot of the second person is a third person who repeats the message as well, which is heard by a fourth person that repeats it the final time. This way the message propagates way beyond my ability to yell. Mesthastic is basically a bunch of small devices that just yell out and repeat short messages. They do not negotiate a network connection in the traditional sense. It's much more simple than that. This is a remote-controlled outlet. When I push this button, a radio signal is transmitted with a simple encoded value that tells the outlet to turn on or off. We can even copy this signal with a flipper 0 and play it back. Whenever a manufacturer wants to make a device that needs to communicate wirelessly, like doorbells, weather stations, or remote controls, they need to find some radio frequency to do this on. The problem is that there is a finite amount of space in the radio spectrum, and in this limited amount of space, there needs to be room for police, fire and rescue, airplanes, ships, GPS, cell phones, Wi-Fi satellites, and lots of other wireless communication. And each type of communication needs to stay in their own dedicated lane, so that we don't get interference across the signals and cause frustrating, costly, or even dangerous situations. Because of this, all radio transmissions are strictly regulated worldwide. No one can transmit anywhere without permission. Devices such as the remote-controlled outlet use a license-free radio band known as ISM, which is short for Industrial, Scientific and Medical, which is the original user's intent for these frequencies, although they are now used for many other different purposes. Wi-Fi and Bluetooth also use some of these ISM bands. There are several of these license-free narrow lanes located in between other frequency allocations. Manufacturers can develop devices that use these frequencies without the user having to obtain a transmitting license, as long as the devices adhere to the internationally agreed upon limitations of low power output and limited transmit duration to make sure that they do not interfere with other devices using the same frequencies. Usually the distances needed by remote controls, sensors and doorbells are fairly short, so these limitations of power output are just fine for this purpose. These devices typically encode their signals as some form of simple frequency shift keying or on-off keying, which you can think of as being basically Morse code, but a bit faster and controlled by a small computer. This is where the term LoRa, or long range, comes in. It's the technology used by Mesthastic that makes it different from regular short-range ISM devices. LoRa is a modulation type developed and patented by the company Cycleo in 2014. It uses something called a chirp spread spectrum technology, which is much more robust against noise and low signal strength than regular FSK or OOK. Since it allows for decoding much weaker signals, it enables the radio signals to be heard at much longer distances, while still adhering to the low power output requirements of the license-free ISM bands. Instead of just controlling a lamp across the room, now a farmer can have a humidity sensor in a field at the other side of his farm, remotely monitored through a LoRa signal. And since the power output is still really low, they can run off small power sources like solar panels. However, the amount of data you can transfer is also very small. LoRa is usable for short text messages, not larger data streaming such as video or sound. You can buy LoRa modules intended for DIY or prototyping projects for very cheap online. They consist of the LoRa radio module and some sort of programmable microcontroller, like an ESP32. Mesthastic is a firmware developed to run on some of these devices. On the Mesthastic website, you can see what devices are supported by the Mesthastic firmware. I've got a few different devices here. Be sure to get one that works on the frequency used in your region. They can all be powered on by simply plugging in a USB cable, but they can also run off batteries. Remember not to power on a device without having an antenna connected, as the module could be damaged otherwise. Having access to a 3D printer to print a case and a soldering iron to solder on a battery connector will make it a lot easier to play around with Mesthastic devices. Flashing the Mesthastic firmware to a device is easily done by using the online flasher and connecting the device through USB. Once the device has been flashed, the easiest way to connect to it is using the Mesthastic app available for both iOS and Android. The initial setup requires you to select what region you are in. This is because the ISM band regulations are slightly different depending on where in the world you live. In Europe, it's most common to use the 868 MHz band, while in the US it's around 906 MHz. This is technically all the configuration you need to do to get started with Mesthastic. In the app, you can now navigate to the tab called Nodes and see all other Mesthastic nodes within range of your device and send messages between them. Most likely this list of nodes will be completely empty, and this is where we have to talk about the use cases for Mesthastic. If you are a group going camping or hiking out in the forest or mountains, each of your friends could carry with them a Mesthastic device, and this would enable you to message each other without having to rely on spotty cell phone coverage. You can even see the location of each device and the range and direction if they enable location sharing. Some LoRa devices have a built-in GPS, but that's only really needed if you are not going to use the device with the phone, since you can also just transmit the location from your phone's GPS. However, some enthusiasts also want to use Mesthastic to create larger mesh networks, covering cities or even larger areas, to create an off-grid alternative to commercial networks or for use in emergencies. This is possible by setting up unmanned nodes in high-up locations with the primary purpose of repeating messages to other nodes within range. Radio communication is mostly line of sight, so if you're walking around in a city at street level and want to send a Mesthastic message to your friend a few blocks away, the message will probably not reach your friend because it's blocked by the buildings, trees or hills that are in the way. But if there is a node on top of a tall building that both of you can hear yelling above the rooftops, this node can repeat your messages so that they reach your friend. If there are several nodes high up, they can hear each other and repeat messages over a much larger area. And as long as your personal node can reach one of the high up nodes, you can send messages through these without needing to have your own personal node be up high. I have set up such a node dedicated for repeating packages on my apartment balcony. This is a Wisblock from RAK Wireless, running off a lithium-ion battery powered by a 5-watt solar panel, using a homemade ground plane antenna. The Wisblock device requires much less power than an ESP32 device and has run easily over a month from nothing but solar power, even in overcast and rainy weather. This allows me to reach other nodes in my city area when I'm sitting on my couch or walking around downtown, carrying with me my personal node. And it expands the total coverage of other local nodes. There are some problems that you need to be aware of before diving headfirst into establishing a huge Mesthastic network. First of all, you need to realize that this is a young, open source project in rapid development with frequent new updates that need to be flashed to the devices. Not everything works all the time. I've experienced several weird bugs and random crashes and needed to manually restart devices, which can be problematic if you've mounted it high up in a hard-to-reach place. And if we truly were in an emergency situation, if you hadn't already downloaded the Mesthastic app, or if you've lost or broken your phone, you probably would not be able to use the Mesthastic devices. It is possible to plug in a Mesthastic device to a computer and use a web interface, although it is lacking some features. One way of solving this would be to have a standalone device that does not need a phone to function. This is the Lilygo T-Deck. It is technically a standalone Mesthastic capable device that allows you to use its keyboard to write messages, negating the need for a phone. However, as of the making of this video, the Mesthastic software for the T-Deck is unfortunately severely limited. You cannot configure the device without a computer or phone. There is no message history, and the way the software reads the keyboard input is so painfully slow that you lose any advantage the physical keyboard could have provided. I cannot fault an open source project for not having perfected the software for this specific device yet, out of all the devices Mesthastic runs on, but there certainly is a lot of unresolved potential for the T-Deck. Another problem with larger Mesthastic networks is congestion. If you manage to convince all your friends to cover your city in Mesthastic nodes, you might run into another problem: too many data packets. Every time a node announces its presence, and every time you send a message, and every time a node transmits telemetry, all of this is repeated again and again and again by all the local nodes. It can cause so much traffic that messages are transmitted on top of each other and are lost, preventing the network from working. You can tweak the settings of your node to lower the chances of this happening, like disabling repeating received packages if your node isn't placed up high. But a single badly configured node can cause a lot of problems. By default, your packages are repeated 3 times, and this is the limit of how far your messages can travel. You can increase this to a maximum of 7 hops, but this is not advisable in most cases. In Europe, the ISM band regulation requires a device to not transmit more than 10% of the time in an hour on the LoRa frequency. If you reach this threshold, your device will go completely silent. This is one of the problems of using this license-free frequency allocation for large mesh networks that it was never intended to be used for. Another problem with trying to create large Mesthastic networks is the low power output limits, which forces you to put up more Mesthastic nodes, which causes more congestion. In Europe, the legal output limit for the LoRa frequency is 500 milliwatts. That's half a watt. Although it seems most LoRa devices transmit at an even lower output. Radio communication is mostly line of sight, and you can find impressive examples of making very long-range Mesthastic connections when standing on the peak of a mountain or even being on an airplane. You can even easily receive LoRa packets transmitted from satellites. However, when transmitting at half of a watt at UHF frequencies, your signal will still easily be blocked by the smallest amount of tree branches and buildings. LoRa is impressively long range compared to a doorbell, but it is not a strong signal compared to other radio options. You will absolutely need to use better antennas than the small included ones to get the most range out of these devices. And preferably the antenna needs to be mounted as close as possible to the device, as longer lengths of antenna cable will lower the signal strength significantly. Mesthastic is a fun and easy way to get started in experimenting with antennas and radio propagation. But being limited to the license-free ISM bands is a bit like being limited to only using the sidewalk. Even if LoRa is like putting on rollerblades and getting the most out of the sidewalk, it is still only the sidewalk. There exists a very similar project to Mesthastic, however, a much older and more mature project that has already been widely adopted around the world. This message is sent directly between these two devices, completely off-grid, without using Wi-Fi or cellular connection. If the message cannot reach the other device directly, it can jump through one or more repeating nodes. This is known as APRS, Automatic Packet Reporting System. APRS works exactly like Mesthastic by transmitting and repeating short data packets that can be used to send messages, report your position, or transmit telemetry information. APRS has been around since the 80s and is implemented in a wide variety of radios and software, and you can even use APRS with a HackRF porter pack. But you can also do APRS by connecting a radio to your computer or even to a smartphone. The cheapest and easiest way of getting started with APRS is getting a cheap radio. You might already have one like this Quansheng, and buying or making this specific cable that allows you to connect the radio to a smartphone running APRS software. Just like Mesthastic, you can now in the app see other nearby nodes appearing in the list. You can send them text messages and see their location and other telemetry information that they've chosen to share. There are even attempts at implementing APRS directly into a custom firmware for Quansheng Radios so that you wouldn't even need a phone. Lots of other radios already come with APRS functionality built in. Unlike Mesthastic, every APRS node is not automatically configured to repeat packages, because this is rarely useful for the network to function properly. Instead, this is done by dedicated repeaters known as digipeaters. These are located in higher places all around the world, put up and maintained by volunteers just like Mesthastic repeater nodes. You can even put up your own digipeaters. But unlike Mesthastic nodes, you probably already have an APRS digipeater within range of you. There is even an APRS digipeater on the International Space Station. Even though APRS can be used completely offline, some digipeaters are also connected to the internet. This is known as an iGate. If you announce your presence near an iGate, any user near another iGate worldwide will be able of sending you messages. There are also services available through APRS, like sending short emails. You can see APRS activity, digipeaters, and nodes in your area and worldwide by going to the website APRS.fi. While Mesthastic can also be connected to the internet through MQTT, the implementation is still a bit iffy and can quickly cause congestion. The big advantage to APRS is the range. APRS can be transmitted at much higher power levels. Where a Mesthastic device might only be transmitting at less than half of a watt, this simple handheld radio can transmit at a much higher output of 5 watts, and digipeaters might transmit at 20 to 50 watts or even higher. APRS is also transmitted at a much lower VHF frequency. In Europe, that's 144.8 MHz. And radio signals at these lower frequencies are not as easily blocked by trees and buildings, and thus get better range. So even though LoRa Mesthastic is using a much better chirp spread spectrum modulation to get every tiny bit of signal through compared to the simpler and less efficient AFSK modulation used by APRS, the higher power levels and lower frequency of APRS causes the real-life range to be much better than Mesthastic. Higher power output is however also a downside, as the digipeaters also require more power and cannot as easily be run off a tiny solar panel like Mesthastic nodes can, but it's not impossible. This is a map of Mesthastic activity in my local area, and this is a map of APRS activity in the same area. Mesthastic is gaining popularity, but APRS currently has much larger coverage and more activity. At this point, I think Mesthastic's best practical use is smaller, temporary, battery-powered networks, while APRS is probably better for larger area networks as a more permanent infrastructure with more users, although both are fun to play around with in all kinds of scenarios. APRS is not using the narrow sidewalk of the radio spectrum though. Instead of using the license-free ISM bands, APRS is used on the amateur radio bands. This means that if you want to play, you have to take a driver's license for the highways of the radio spectrum. Amateur radio is also known as ham radio, and both are terrible names for it. Really, it should just be called hobby radio. If you've been playing around with Mesthastic, you've already been engaging in hobby radio. Playing around with antennas, doing range testing and experimenting with new protocols is exactly what amateur radio is all about. But instead of being limited to a few license-free narrow bands with strict output limitations that are shared with other equipment, amateur radio has a bunch of different dedicated bands with much higher power levels allowed. To make sure that you know how to make sure that your experiments do not interfere with other radio communication, however, you need to take a simple test before getting a call sign and being let loose on the amateur bands. It's not really that difficult, and I highly recommend it if you're having fun experimenting with Mesthastic. There is a whole world of similar stuff to play around with on the amateur bands. You can communicate through satellites or the International Space Station, reflect signals off shooting stars, and experiment with low signal modulations on the shortwave bands, having your signals reflected off the ionosphere and reach all around the globe. There is even a Mesthastic-like modulation type made for shortwave, and some of these can even be run off a smartphone connected to a handheld radio. Right now, in this very moment, there are radio signals all around us just waiting to be received and decoded. If you have not yet played around with Mesthastic, I highly encourage it. It is cheap and easy to get started. If you're already having fun with Mesthastic, I think you would also enjoy the radio amateur hobby and the many similar activities that it offers. And maybe you can even help expand the APRS coverage in your area. I hope this video has given you a small insight into the world of Mesthastic and APRS.